Alright, this is paper number 13, brought to you by Mr. Graham. And the first question is to do with areas. So hopefully what you'll recognise is you have a trapezium, and you have various lengths that are marked on. So you have 8, 7 and 10. We're noticing there's right angles, and of course it's not drawn accurately. So it's a question where you need to use some kind of formula for finding the area of a trapezium. Now if you look back at your formula page, you should see a formula, and the formula should be half of a plus b times h. So the question really is, do you know what a, b and h are? So h is the perpendicular distance, which is this distance here, so that's what h is, between the two parallel sides. So the parallel sides are these two here, and we know they're parallel because of the right angles there. So that's what a and b are. So it's a matter of then using the formula. So what we have is half of 8 plus 10 times it by 7. Now 8 plus 10 is 18, half of 18 is 9, so it's 9 times 7, and that is 63 meters squared. Alright, so that's question 1. Question 2 is algebra. Firstly you have expanding, then you have factorizing, which are really the reverse process of each other. So expanding a bracket like this just means doing c times c and c times minus 3. And remember, it's multiplications, so it's c squared is c times c, take away 3c, not c3. 2b, factorize 3d plus 12, looking for numbers and letters that are common to both. Alright, so you're looking for numbers that's common to 3 and 12, the highest common factor of 3 and 12, which is 3. And then you're looking also for letters they have in common, but they don't have any letters in common because this does not have a letter. So it's 3 upon, open your bracket, 3 upon d plus, and you're just really thinking, so it's 3 times d to get 3d, and it's 3 times what to get 12? It's 3 times 4 to get 12. So question 3 is about function machines or number machines, where you put numbers in, do some operations to them, whether that be adding, subtracting, multiplying or dividing by a particular number, and then you get an output. And all of these are about two-stage operations. That just means we do two things. Right? Each box represents the two things you can do. So the first part of the question is putting in negative 3 and getting out 20, and we've got to work out the two operations that we can do. B is putting in negative 3 and getting a negative out, so that's our understanding of how numbers change when adding or subtracting by a negative. And then part C is about getting the maximum possible answer. So we'll look at each of those in turn. Starting with 3a, to get the answer 20, it's a matter of playing around with it. So you're going from a negative to a positive, so maybe what might seem the obvious thing to do first is add 7 to get 4, and then times it by 5 to get 20. So there is one way you can get the output of 20. I'm not sure that there's any other ways. Part B, there is lots of different ways to get the answer. So you want to get a negative as an answer. So we could, let's see, turn it into a positive by adding 7 again to make it 4. And then to get a negative answer, we could either take 7 to make it minus 3, or times it by negative 5 to make it negative 20. So there's actually lots of answers that work for part B, and it's about just checking that yours is a correct one. Finally then, two operations, so the output is the maximum possible. So you're starting with a negative, and really what you want to end up with is a big positive number. So one way to do that is the understanding that basically if you times it by negative 5, alright, you get positive 15. Alright, so that's I guess the biggest possible number so far. And then if we times it by positive 5, that gets us 75. So we could have done that the other way around. Of course they're interchangeable. We could have times it by 5 first to make it minus 15, and then times it by negative 5 to make it 75. So it's about realizing that what you really want to do in this case is to get it as big as possible, and that's how to get it big and positive. Okay, on to question 4. So once again what we should do is read the whole question. So we've got the heights of the players in the school basketball squad in centimetres. And we seem to have 10 heights, and of course those people being basketball players will be taller than the majority of you. We've got to complete an ordered stem and leaf diagram, and then further on down we've got to answer questions on the median, and then there's an understanding question, part C, upon that as well. So let's look back at the start then and see what we have. So an ordered stem and leaf diagram. There's room here if you want to get yourself organised, and then as you get yourself ready, you can go down here and put it in order. And of course here's the clue here, 17, 18, 19 there are 170 something, 180 something, 190 something. So you're given sort of how to do it down there. Now because there's so few, you might be able to put them in order already, but let me just do it by going 17, 18, 19, and that's 170 something, 180 something, and 190 something, and then just going through them in order. 187, 179, 184, 186, 190, 186, 181, 194, 188, and 177. Alright, so now I'm putting those in order. So 177, 179, 181, 184, 186, so it goes 6, 6, 7, 8, 6, 6, 7, 8, and 190 and 194. So check you have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have them in order. And of course it said don't forget to fill in your key, so we won't. So any of those numbers or any other number, 1, 7, say 9 represents 179 centimetres. Right, so there's your ordered stem and leaf diagram. Write down the median height. Now there's one mark, but the median, to find the median, it is halfway. So if there's 10 in the line, we should find the place where there is 5 less and 5 more. So one way to do that would be to count in from either end. So there's basically 1 there, and 1 there. Okay, so counting in from either end till you get in the middle. So we have 2 numbers in the middle. They're both the same, 186. So the median height is 186. You could do it similarly by realizing there's 10 values. To find the middle, you add 1, divide by 2. That tells you where to find it, which is the 5.5 value, or halfway between the 5th and the 6th, which is really what we have there. 1, 2, 3, 4, 5, 6, so the 5th and the 6th, and halfway between them. Alright, so really the same thing. Then going on to 4 part C, another player of height 188 joins the squad. Explain why the median will not change. So taking a minute to think about this, 188, if I just take and put on where 188 would be there. And the median person would now be the 6th. So with a similar logic we would now have 11. To find the middle you add 1 divided by 2, that's where to find it, which is 12 divided by 2, which is the 6th value. Now the 6th value we can see is 1, 2, 3, 4, 5, 6, so it's still 186. And in terms of an explanation, you just need to write something like the 6th value is still 186, as there was 2 186s, or something like that. But something about the 6th value being 186, and maybe mentioning how there was 2 186s, and that is why it is still the median to be 186. Okay, on to question number 5. So it says use approximations to estimate the value of. Now if you're doing approximations, really an estimation, really what you're doing, this bit here, is rounding to one significant figure. So every number should be rounded to one significant figure. You should do the calculation and see what you get. So 5.87, one significant figure means here's the first significant figure here, the units column. So it's really saying is it closer to 5 or 6, and 5.87 is closer to 6. Multiplied by, it's then saying 101, the first significant figure is the hundreds column, so it's saying is it closer to 100 or 200, of course it's closer to 100. So that is the square root of 100, divided by, And then the last one here on the bottom is the first significant figure is there, which is the units column, so it's really saying is it closer to 1 or 2, and it's closer to 2. So that's what you have to work out. 6 times the square root of 100 divided by 2 squared. The square root of 100 is 10, so you're really doing 6 times 10 divided by 4, so that's 60 divided by 4, and of course, please don't write outside that box. So 60 divided by 4 is 15. Okay, question 6. Lewis is buying a caravan. Good for Lewis. The cash price is £8,000 and he buys it on credit in the following way. So buying on credit just means he doesn't have the money to pay for it up front, so he's allowed to pay it off over time. So in the box we have the arrangement. Paying a deposit of 15% of the cash price plus 24 monthly installments of £350. 6a, show the total credit price is £9,600. So paying by credit means that over the 24 months you'll end up paying more, but you'll be able to afford it as you go along. 6b, as we look down, we have to pay later. An extra 1,000 is bought on credit, and what's that as a percentage? So a bit of percentages and a bit of adding and subtracting to do. So let's see. So show the total price is 9,600. So what we've got is 15% of 8,000, and 15% is divided by 100, which is 80, and times it by 15. So we need to do 80 times 15, or the other way around might have been easier. So that's 400 plus 800, which is 1,200, and then we need to do 24 times it by 350, and 24 times 350 is the same as 12 times 700. Some of you might be able to think about it like that. Some of you might be able to cheat a wee bit and think, well, because I know what the answer is, I know that must be 8,400, because those two bits together, 1,200 plus 8,400 equals 9,600. So be clear with what you show. When you have to show something, make sure you're clear where your calculations come from. 6b, 1,600 is bought on credit. What is that as a percentage? So basically, first of all, what is it as a fraction? So 1,600 as a fraction of 8,000 would be written like that. So to turn a fraction into a percentage, firstly you can simplify the fraction. So to do that, we've got 16 over 80, divide top and bottom by 100. Of course we could simplify it further. You might know that 16 goes into 80, but if you don't, divide top and bottom by 2 or by 4. But eventually you'll get down to 1 over 5. And then at that stage, some of you might know the answer. 1/5 is 20%. Of course, the kind of formula to do it is just to take 16 over 80, that's written as a fraction, and then you times it by 100 to turn it into a percentage. But sometimes it's just easier. Can you cancel it down, and then maybe it'll become apparent. Okay, on to question 7. So once again, looking down, we've got a triangle. We've got to work out the value of x, and hence or otherwise. And normally when you have a hence or otherwise, it means use what you've just got, work out the perimeter of the triangle. So, the key in the question really is, did you read it? The triangle is equilateral. What does that tell you? You're given information about the sides, and it says work out the value of x. So, an equilateral triangle has all its sides equal. So, setting x plus 4 equal to 2x minus 1. If it's equilateral, those are equal. You could, of course, do 14 minus x equals 2x minus 1, or x plus 14 equals 14 minus x. So if we do that, if we take away x from both sides, now if we add 1 to both sides, we get x is 5. So hence or otherwise work out the perimeter of the triangle in part B. We can go back here, and if we put x equals 5 in, we get 9. Just checking the other ones work. 9 and 9. So it's an equilateral triangle. All the sides are length 9. So that's why it is only worth 1 mark down here, because it's basically 9 plus 9 plus 9. Or 3 times 9, which is 27 centimeters. Moving on to question 8. So we have two triangles drawn, and we have to draw the image of t after a 90 degrees anti-clockwise rotation about 0, 1, and then describe fully the single transformation that maps t on the W. So the image of t after a 90 degree clockwise rotation. So let's see. T is the top triangle, and it's 0, 1, making sure you get 0, 1 to be here, not the other point that you might think it is. A 90 degree anti-clockwise rotation, you should put your tracing paper on top of T and the point, trace over this with the tracing paper over it, mark the tracing paper at the top, and then turn it 90 degrees anti-clockwise, that's the opposite direction of the clock, until that line is facing in that direction, and then see where your shape would be. So your shape will end up being up here if you've done it correctly. So it should move, okay, it should move up to there, and you can check to see that's correct. That is your image. It doesn't tell you to mark it in any special way. Sometimes you mark it with a T dash. The second part is to describe fully the single transformation that maps T onto W. Now, a single transformation will either be a rotation, reflection, translation, or enlargement. A translation, the shape will have the same projection but just in a different place. For instance, if you were to move T to a different position, sort of anywhere like this, but in the same projection, then it would look like that. That's going to end up looking like a translation. A reflection will be a mirror image, and a rotation will turn it. Now this cannot be a rotation, because if you rotated it this way, you would end up with a shape sort of in that direction somewhere. So once again, that can't be the correct image either. And of course in this case, it's not been enlarged either, so it looks like it has to be a reflection. Now reflections will either be in a vertical line or a horizontal line, or at the very worst, as in this case here, it will be in the line either y equals minus x or y equal to x. So it looks like it's been a reflection, and if you turn your page around so it's in the mirror line, you'll maybe see that. So let's write that down. Firstly, you need to write the word reflection. So you need to write whatever the transformation is, rotation, reflection, enlargement, translation. Then you need to describe the reflection. In the case of a reflection, it will be in the line, and you'll need to write the equation of the line. In this case, it is y equal to negative x. On to question 9. Back to a bit of algebra. So indices work. So when you're multiplying and the bases are the same, you can add the 6 and the 4, because really what you're saying is it's m multiplied by itself 6 times, then multiplied by itself 4 times, which is the same as m multiplied by itself 10 times. And a similar rule here, when you're dividing and the base is the same, you can subtract the indices. So it is h to the power of 12 take 4, which is h to the power of 8. Question 10, a ratio question. Ruth, Sally and Jenny share £500 between them. So you're given the total amount. You're told Jenny receives 120, and the ratio of Sally's share to Jenny's share is 4 to 3. And you have to work out the ratio of Ruth's share to Sally's share. Now, this mightn't be the most traditional way you're asked a question, but just take your time to read it. Think about the 3 people involved. Think about how much they might have and the various ratios. So we've got Ruth, we've got Sally, and we've got Jenny. What do we know? We know that Jenny got 120 of the 500, and the ratio of Sally to Jenny is 4 to 3. So what you're thinking about, the ratio is 4 to 3. So as you can see, really what you want to do is use this bit here to think, well, Jenny's 120 is 3 parts. So if the 120 is 3 parts, it's 120 divided by 3. 1 part is 40. Right? 1 part is 40. So Sally is 4 parts, so that's 4 times 40, 160. And then the question is really saying work out the ratio of Ruth's share to Sally's share. So we need to work out how much Ruth got. So it's 160 plus 120 so far. So 160 plus 120 is 280, and that leaves you, if you take that away from 500, 220. So the question really then becomes, what's the ratio of 220 to 16? So I'm just going to write over here, 220 to 160, divide both sides by 100, divide both sides by 2, so it is 11 to 8. And make sure you write it the right way around, it's Ruth to Sally, it's 11 to 8. So a question like this, take your time, work out anything you can first. Think, well, I'll work out Jenny, I know Jenny's amount, I'll work out Sally's amount, and just keep working your way from there. So this is a question you can do if you just make sure you take your time. So question 11 seems to be to do with perimeter, and we're given information at the top on a semicircle and a rectangle, the diameter of the semicircle, the length of the rectangle, which is just repeated beneath, and then we're told work out the width of the rectangle marked x, so we've got to work this length out, and we've got to use pi to be 3.14 if need be. So the key part here really is that they have the same perimeter. Okay, so we're really going to set an equation up and put the perimeters equal to each other. So looking at the semicircle first, the perimeter of the semicircle is the curved bit here plus the straight bit. Okay, it's the curved bit plus the straight bit. So if we think about the curved bit formula is C equals pi d is the formula for the circumference of a circle, and this is half the circumference of a circle. So the diameter is 20, so the circumference would be 20 times pi, but we want half of that. So the curved bit is 10 pi plus the straight bit is 20. So you can see we have the curved bit plus the straight bit equal to, and then for the rectangle the perimeter is all four lengths added up, so it's 15 plus 15 is 30, plus x, which is plus 2x. At this stage then we can put in pi to be 3.14, so 10 times 3.14 is 31.4, plus the 20 equals 30 plus 2x. Simplifying the left hand side is 51.4 equals 30 plus 2x. Now we've got to solve an equation. Take away 30 from both sides, so take away 30 from both sides, and that gives us 21.4 equals 2x, and we have to divide 21.4 by 2, so divide both sides by 2, and if you're not sure what that is, just do the sum. 21.4 divided by 2, 2 into 2 goes once, remainder none, 2 into 1 doesn't go, carry the 1, 2 into 14 goes 7 times. So if you're not sure, take your time and work it out.
Okay, question 12. Paul has two six-sided dice, or regular dice. He knows that one is fair and one is biased. Describe how you can find which is the biased dice. So it's 4 marks. Guess what you should be thinking 4 marks is sort of 4 points, especially with the room given. So it's a matter of thinking, right, well, what would I do? And then try and put that down on paper. So really what you're going to do is you're going to take each dice, you're going to roll it lots of times, and then you're going to see that one of them, all the numbers, 1, 2, 3, 4, 5, and 6, should happen about the same amount of times. And the biased dice will have numbers that happen a lot more than others. Alright, so it's just a matter of putting that down. So something about, first of all, I guess your first point should be something to do with roll both a lot of times, but maybe roll both, say, 600 times. So a lot of times. Any number bigger than 30 would be regarded as a lot. Secondly, record your results. Record results in a table. Alright, or some way of recording results. It doesn't have to be exactly that. And then your analysis of that. So you've rolled it, you've seen what happens, what does it show? The fair dice, so the fair die should have 100 each, 100 of each number roughly. Okay, because a sixth of 600 is 100. The biased dice will not Okay, so the biased dice will not. Okay, but something like that. Okay, question 13, solving an equation. Now when you're solving an equation like this, the problem bit is the fraction bit here. There's a couple of ways you could do it, so I'll show you both ways. When there's just one fraction like that, what you can actually do is just take 5 from both sides. Okay, take 5 from both sides to get rid of the plus 5 at the start. If you do that, you have w over 6 equal to, 2 take 5 is minus 3. And then times both sides by 6. To get rid of the divide by 6, I have to do it to both sides, and we should get the answer w equals minus 18. Of course, you could do it slightly differently. You could, at the very start, alright, you could at the very start, if I just write it out here to the right-hand side, get rid of the fraction straight away by multiplying everything by 6, so multiply both sides by 6 at the start. Just being careful when you multiply both sides by 6 to multiply the 5 by 6, the w over 6 by 6, which gets rid of the divide by 6, and the 2 by 6. If you do that, you would get 30 plus w equal to 12, and then you need to take away 30 from each side to get w by itself. So doing that will get you w equals minus 18, the same answer. Either way is totally fine. 13b, make x the subject of the formula. Making x the subject means getting x by itself, so what we want to do is get 3x by itself and then x by itself. To do that, the first thing you have to do is take away 7 from both sides. So if you take away 7 from both sides, you get y takes 7. And then to get from 3x to x, you divide both sides by 3. So that is y minus 7 over 3. So let's be careful, write the answer out. X equals y minus 7 divided by 3. Finally then, in this page 13c, it says n is an integer. So we need to know what an integer is. So an integer is any whole number, positive or negative. So something like -2, -1, 0, 1, 2, and keep going both ways. So that's what an integer is. Now a question like this, when you have a double inequality, so an inequality there and there, you're really looking to do 4n bigger than minus 16 and 4n less than or equal to 12. So you can split it up into 2, but in this case, because it's reasonably straightforward, you can actually just divide by 4, all right, to get minus 4 less than n less than or equal to 3. Right? But really you can split it into 2 parts. Right? You're solving 2 inequalities there. You're solving the first inequality, which is 4n is bigger than minus 16, in which case n is bigger than minus 4, and 4n is less than or equal to 12, in which case n is less than or equal to 3. So now going back to the question, n is an integer, and you have to list all the values of n, integers that are bigger than minus 4 and less than or equal to 3, so that's minus 3, minus 2, minus 1, 0, 1, 2, and of course it can equal 3 because of this bit here. It can equal 3, but it can't equal minus 4.
Question 14, cumulative frequency. So cumulative frequency is a running total. It's the idea of less than a certain amount of time you have so many people. So what's this one to do with? It's the general 40 people. So it's telling you how many people, and you should see right at the top of the graph here, it should go across to 40, which it does. So in terms of something like that, this should be your, if it didn't tell you 40, you would know it was 40. So what we're being asked to find in this question is to draw a box plot of this information. Now a box plot, what you should know is, you should know a box plot is something that looks like this. So what we need is the lowest value, which is the one at the end here, then the lower quartile, the median, the upper quartile, and the highest value. So the box really represents the middle 50%, and then we have the whiskers, because it's really also called a box and whisker diagram. So the whiskers go to the lowest value and the highest value. So you're told the shortest journey time was 7 minutes. So what you need to mark on is 7, and of course it's going to be harder for me to do this on the screen, but if you look there is 7. The longest journey time, if you look at the longest journey time up here, the longest journey time as you read down seems to be at 58. Right, so if you read down at 58 there, you can see the longest journey time. So we can mark on 58 here and be careful to mark it on in the right place. And then we need to read off the other values. So It's really a mixture of, do you understand the median is read off at 20? And of course you need to make sure you read yours off well, so that 20 should read off at 34. So we need to go to 34 to draw it on. Then if we go for the lower quartile is at 10, so reading 10 to the line and down seems to be 23. So we put it on at 23. And the upper quartile will be at 30. So 30, so 3/4 of 40, across to the graph and down, and that should be reading off at 42. Right, so reading off at 42, so being careful to put on at 42. And then those ones are joined by a box, and like that. Of course, you should use a ruler. So, alright, part B, estimate the number of people who take longer than 45 minutes to travel to work. So let's go back to our original diagram. Longer than 45 minutes to go to work. So here's 45 minutes, going up to the graph and across. Oops, a wee bit wrong there. So that should be coming out at 33. Now, what you need to realize about cumulative frequency is it tells you less than a certain value, less than a certain time. So less than 45 minutes, there was 33 people. So what's our question asking? It's asking us for longer than 45 minutes. So if there's 33 people taking less than 45 minutes, there is 40 take away 33, 7 people taking longer than 45 minutes. Okay. Is it better to use the cumulative frequency diagram or the box plot to work out the answer to part B? And the cumulative frequency diagram is really the original, where the original information came from. So it would be better for us to use that diagram. We can't really seem to read over 45. The box plot really only just tells us the key information, the key values. The cumulative frequency diagram tells a lot more. Okay, 15. Solve the simultaneous equations. Now you might be put off here by the fact it doesn't look something like this. Alright, so where you have x's and y's directly above each other, but it's really the same kind of question. So maybe the best way to do it is to put it in a way that you're more familiar and do it by elimination. Some of you, of course, might be able to do it by substitution. So by substitution would be taking the x equals y plus 3 and substituting it into there. So there's two ways you could do this question. Alright, so maybe the majority of you might be tempted to do this and bring the y to the other side and make it x take y equal to 3. In that case, what you need to do is get both the y's to be the same. So that would be 3x take 2y equal to 5. You could leave that one alone. But the bottom one you could times by 2 to make it 2y. Right? So if we get this to be the same amount of y as the one above. So times it by 2, we get 2x take 2y equal to 6. Now, there's two schools of thought here. One is to make one of these a plus and one a minus. Alright, so we could do that. Or we could take the two equations away. So I'm going to go for multiplying it by minus 2 to make it minus 2x plus 2y equals minus 6. And then I'm going to add the two equations together to eliminate the y's. So if I do that, I get 3x take 2x is x equal to 5 take 6, which is minus 1. So x is minus 1. Put it back in to either of these two equations. So if I do that, I get 3 times minus 1. Well, actually slightly easier would be, let me just rewind. Slightly easier would be to go back maybe to the top and use the equation here. Maybe a slightly easier, x equals y plus 3. So let's put it in there. So x is minus 1 equals y plus 3, and take 3 from each side, y is minus 4. So the answer is x is minus 1 and y is minus 4. And of course you can check that by putting it into your original problem. Check x is minus 1, check y to be minus 4, and see if that works. Right, so on to the next. The two diagrams, so similar rectangles. Keyword here, similar. Right, similar rectangles, so this is to do with similar shapes. And the question is not drawn accurately again. So work out the shaded area can still be seen. So it's all about similarity. So really what you need to realize is that to get from here to here, alright, what have we done? We need to do the same to this side to get this side here. So 8 is 2/3 of 12, or you can think of it as 8 times 1.5 gets 12. So I'm going to think of it as it's 2/3. Right, so the right hand picture is 2/3. So 2/3 of 9, 9 divided by 3 is 3 times by 2 is 6. So it's 6 and 8, or 9 and 12. Or another way to think about it is that 9 is 3/4 of 12, so what is 3/4 of 8? So the shaded area, so this is a question really then, once you have that, it's a matter of saying 9 times 12 is 108, that's the area of the big rectangle. 6 times 8 is 48, that's the area of the small rectangle. Take it away, and that leaves you with 60, and that is 60 centimeters squared. And it says here, state the units of your answer. So we wouldn't want to lose a mark by not stating the units of the answer, so that is 60 centimeters squared because it is an area. 17. Work out 3 times 10 to the 7 divided by 6 times 10 to the 4 in standard form. Now, you could write it all out as ordinary numbers and do the division, but when you're doing standard form calculations without a calculator, when you're doing a division like this, we need to do 3 divided by 6. So that's really a half, or 0.5. And then we need to use indices, which was earlier in the paper. 10 to the 7 divided by 10 to the 4 is 10 to the, and it's 7 take 4, 3. Now that would get you 1 out of 2. The reason to get you 1 out of 2 is that there is not a number between 1 and 10. So a number between 1 and 10 would be 5 times something. So if you have to multiply 0.5 by 10 3 times, you're only going to have to multiply by 5 by 10 2 times. So it's 5 times 10 squared is the answer. Right, 17b is a similar kind of question. It's can you square that? Of course, squaring something means multiplying it by itself. So it's really asking you to do 4 times 10 to the 3 times 4 times 10 to the 3. And with multiplication, what you need to do really is just do 4 times 4. Do that multiplication first, which is 16. And then times it by this multiplication, which is times 10, and the same as earlier, 10 to the 3, times it by 10 to the 3, you add the indices, so that's 10 to the 6. Like the last question, that is not a number between 1 and 10, so it is a 1.6 times 10. Well, if you have to do 16 times 10 6 times, it's going to be 1.6 times 10 7 times. Question 18 to do with indices. Hopefully it's things that you have learnt, which is firstly to the power of 0 means it's equal to 1. And then part B, 2 to the minus 4, a negative power does not mean a negative answer. A negative power is to do with fractions. So have you learnt that negative powers are to do with fractions? So it's 1 divided by 2 to the power of 4. And 2 to the power of 4 does not mean 2 times 4. It means 2 times 2 times 2 times 2. So that is 1 over 16. Now, question 19 is a trigonometry question because we're being given tan and sine. So we're looking for right angle triangles, and we're trying to remember that sine is O over H, cosine is A over H, and tan is O over A. Now, there's a bit more thinking to do in this. We're trying to find out the length AD. So the length AD is here. Alright, and let's say, give it a name, I'm going to call it Z. And in order to work out from that right angle triangle, I'm going to need to start with the right angle triangle on the left, ABC. So the triangle on the left, ABC. So we've got the triangle ABC. We know the angle X. We know this is 4. And because we're given that the tan of X, right back at the top, is 0.6, it really must be to do with the following. So we have, there's the hypotenuse, there's the opposite, there's the adjacent. So really what it is can we find the length of that side, and I'm going to call that, say, W. So the tan of X equals O over A, looking back at the top, which is W over, let's see, 4. The tan of x is 0.6, so 0.6 is w over 4. So w is times both sides by 4, 2.4. So I now know that this length here is 2.4, AC. So I can now think about a second triangle. So a second triangle would be, and I now know that is 2.4, and that angle there is y, and I want to find this length z, and I know it is to do with sine, because that's what's given at the top. So the sine of y equals over h, so h is the hypotenuse, opposite y is there, so it's 2.4 over z. Now if I look back at the top, sine y is a third, so let's change sine y to be a third. So a third equals 2.4 over z, and multiply both sides by z, multiply both sides by 3, or just in this one particular case, if you have a fraction equal to a fraction, you can cross multiply and say z equals 3 times 2.4. Do that at the side if you need to. Okay, take your time to get it right, which is 7.2. So z equals 7.2. Question 20, factorising, and it's a quadratic, and it's a quadratic because of the n squared. So 4n squared plus 8n plus 3. Some of you will get this by splitting the middle term, so in other words writing it by taking the 8n and splitting it up into two parts, and those two parts you can get from doing the product and the sum. The product is 4 times 3. Alright, so 4 times 3 is 12, so product is 12, and the sum is this number here, 8. So if we do that, we have the sum is 8, and the two numbers are 6 and 2, and you can follow your method on. Let's just look at it a slightly different way. What we should know is the answer will look something like this. So because we know the first term in each bracket multiplied, I get 4n squared, it's either going to be 4n and n, or 2n and 2n. The second term in each bracket multiplies to get 3, and really the only way we can do that is with a plus 3 and a plus 1, or a minus 3 and a minus 1. Then underneath what we have is these two multiplications make up to the 8n, and because it's plus 8n, it is going to have to be plus 1 and plus 3. And then it's a matter of thinking, is it 4n and n that would fit in, or 2n and 2n? So with a bit of working out, you can see it's 2n, because that gets you the 4n squared on the top, gets you the plus 6n, plus 2n makes a plus 8n, and the plus 3. So just putting that in the answer box, 2n plus 1 and 2n plus 3. Alright, part B, using your answer to part A or otherwise, work out the prime factors of 483. Now, prime factors of 483 is taking 483 and dividing it by prime numbers. Now, you might be able to see straight away that 3 is a prime factor of 483 because 4 plus 8 plus 3 adds to get 15, and because 15 divides by 3, so does 483. Of course, that only works for 3, but let's do it. 3 into 4 goes once, remainder 1, 3 into 18 goes 6, and 3 into 3 goes once, and you would keep going. Let's come back to that in a moment, because let's see how we could use the previous part to help us. So if we look at it, we have the 483 is what we're trying to find the prime factors of, and here in the question we have a 4, an 8 and a 3. So how do those two relate together? And it's really a matter of realizing it must be 4 times 100 plus 8 times 10 plus 3 makes 483. So what would n have to be? So n would have to be 10. So you're really saying 483, if n is 10, is this quadratic expression above. And because we've written it as a multiplication, we've really written it as, looking back, as 2n plus 1 multiplied by 2n plus 3. Now 2n plus 1 is 2 times 10 plus 1, which is 21, and 2n plus 3 is 2 times 10 plus 3, which is 23. So you might think that's the answer, but of course you should realize that 21 is not a prime number, and it is actually 3 times 7. So that's how we get the answer from the previous part.
But just carrying on with here, it would be realizing at this stage that 7 goes into that twice, remainder 2, 7 to 21 goes 3 times, and 23 is a prime number to get the same answer. Alright, question 21. So we're on to a histogram question. So a histogram, the key thing about a histogram is that the area is the frequency. Okay, the area of each bar is the frequency. That is the key thing to try and remember. And there is, of course, an equation you can remember, which is frequency density is frequency divided by class width. But if you remember area is frequency, that should be helpful. So in this question, what are we asked to do? Well, we're asked to fill in the missing number in the frequency table and complete the histogram for 2 marks. So we'll start with that. So let's see the missing number and the missing bar. So firstly, let's do the missing number. So let's get this number here. So what we have to do is think between 30 and 60. So the width is 30. And the height measures, let's see, 0.8. So the question is really saying, what is that area? 30 multiplied by 0.8. So 30 times 0.8, so 30 times 0.8. Is this the same as 3 times 8, or 24? Okay, so you can take your time to work that out. 30 times 0.8, one of the key things is you're multiplying by a number less than 1, so you should get a smaller answer than 30. So 24, it's really 4/5 of 30. Alright, so let's just fill that in the table. So filling that in the table, we have 24. Okay, doing the bar by the same kind of idea, we have, it is 150 to 210. That is 60 across. We want the area to be 90. Right, we want the area to be 90. So really what we're saying is it is 60 times what to get 90, or 90 divided by 60. The frequency is 90 divided by the class width. And the class width is the difference between 150 and 210, the difference between these two numbers. And the frequency is 90. So it's 90 divided by 60, which is 9 over 6, which is 3 over 2, which is 1.5. So we need to draw that at 1.5. So that's where our bar should be there. So that bit should be our bar. We don't need to shade it in. That's just for you to be able to see it a bit more clearly. Okay, the next part of the question is part B. Estimate how many vehicles are in the car park between 120 and 180 minutes. So 120 to 180, there's 120 there. So that's 120, and 180 is here. Oh, just there. So we basically need to find out the number, how many vehicles in the car park. Is just saying what's the area of that bar, because the frequency is the area. So really 2 bars to work out and add together. First bar is 30 multiplied by 2. That bar there is really 60. So that's 30 times 2, which is 60. And the other bar seems to be 1.5 times it by 30. Okay, so 1.5 times 30. Alright, so take your time to work that out again. 130 plus half of 30 is 45. So this area of that bit is 45. So add those two together and we get 105. Question 22 looks like it's to do with angles, and there's circles involved, so it'll be to do with circle theorems. So we're always thinking about circle theorems in a question like this. Now the information at the top in the diagram, TAP and TCQ are tangents. So there's TAP along the top, there's TCQ there, and a tangent is a line that just touches the circle. You're told the centre is 0 there, or O, and B lines in the circumference of the circle, so they're just confirming the B's on the circumference, and they're telling you about 2 angles which are drawn on the picture. So 22A is to work out the size of angle AOC, and 22B is to work out the size of angle ATC. So AOC is this angle here, and ATC is this one. So part A, first thing we have to do is work out AOC. Now, any kind of circle theorem question, if you're given the centre of the circle and a line that goes from the centre of the circle to the outside, to A, to B, and to C, each one of those is a radius, which are the same length, and that's going to be very helpful when working some problems out. So I know I need to work out AOC, but I'm going to try to work out any angle I can to start with. So the first thing I can see is that this angle here is 40, and that's 40 because we have an isosceles triangle. So 40 and 40 is 80, which means this angle up here is 100. We can keep going. What we have here is then the next thing I see is circle theorem. That is 90 degrees, the angle between a radius and a tangent. So if that's 62, take it away from 90 to get 28. And because we have an isosceles triangle here, we also have that this is 28. Okay, the picture's getting a bit messy. And we have to show our working out. Now, although it says to show your working out, this here is our working out. Okay, so working out is shown on the same page, so somebody marking it will see. So to confirm then the next bit, we have 28 and 28 is 56. Take it away is 1, 2, 4. So to work out angle AOC, angles around a point, to get 360. So it's 360, take away 1, 2, 4, take away 100. Alright, so the answer to that question then will be 360, take away 224, and the answer to that is 136 degrees. The second part of the question then is to work out ATC and show your working again. So if we go back to the top and back to the idea of quadrilaterals, we have a four-sided shape, and the angles inside a four-sided shape add up to get 360. What we know so far is from the same circle theorem, the angle between the tangent and the radius is 90. So we know two of the angles are 90, and we've already worked out AOC. AOC again is the angle 136. So all we have to do is work out whatever's left. So to do that, we're going to do basically 180, or just to confirm, basically if we have two angles that add to get 180, the other two angles make up to 180. So the one we're trying to find plus 136 is 180. So going back down, 180, take away 136, gets us the answer, which is 44 degrees. And of course we can put that in the answer box, 44 degrees. Okay, question 23. Now you'll not make much progress with this question unless you realise it's testing you about surds. So although we have to find the mean and the median of these numbers, it's really testing that how do you simplify these numbers first, because to find the mean you need to add them up and divide by 4. So how are you going to add them up in this form? So it's realising root 3 plus root 12 isn't root 15. The only way to add them together is if they all have the same square root bit. So simplifying them, firstly you have root 3, you can write it down as it is, root 3. And you also have root 12. Now root 12, if you look for the biggest square number that goes into 12, it's 4. So it's really root 4 root 3. Although I shouldn't write above that box, it's just for you to see. So that is, simplifying that is 2 root 3. Right, so 2 root 3, because root 4 is 2. Carrying on then, root 48. Root 48 is root 16 root 3. And there's a bit of a giveaway, the fact that it seems to be root 3 that's coming up. So we've had a root 3 here, 2 root 3. So basically what root 3 is root 48. But simplifying it, biggest square number is 16. So that is 4 root 3. And the last one, root 75, is root 25 root 3. And root 25 is 5 root 3. So there are the four numbers, and that's what we need to work with. So firstly, the median. Now, the median is the middle of those, and the middle of those four, as we're in order, is in here. So what is halfway between 2 root 3 and 4 root 3? It is 3 root 3. And we're trying to show the mean and the median are the same. So the mean is all the numbers added up. So be clear, it says show clearly you're working out. So root 3 plus 2 root 3 plus 4 root 3 plus 5 root 3. And of course, when you're finding the mean, add them up and divide by how many there is, which is 4. So how many root 3 do we have? We have 1, 2 is 3, 4 is 7, and 5 is 12 root 3. And 12 root 3 divided by 4 is 3 root 3. So we've shown they're both the same. Right, so there's the question finished. Moving on to question 24. So question 24 is an algebra problem, and of course this bit in the middle here is an identity. It's really saying that x squared plus ax plus b is always equal to x minus 5 squared plus a, no matter what x is, and we've got to work out a and b, what numbers those are. So it seems it would be sensible to multiply the right hand side out, so x squared plus ax plus b is equal to, and remembering that x minus 5 squared is x minus 5 times x minus 5, so it's x minus 5 times x minus 5 plus a. Multiplying that bracket out, we get x squared minus 5x, so altogether that's take 10x. Minus 5 times minus 5 is plus 25. And don't forget about the plus a. Now you're really saying those two sides are identically equal. That means you're not solving an equation. You're trying to say, well, the coefficient of x squared should be the same, because it's always true for no matter what value of x. The coefficient of x here, which is a, should be the same as the coefficient of x here. So that gives us straight away what a is minus 10. And then to finish, we're saying the number plus b must be the same as 25 plus a. So we're saying b equals 25 plus a. And we know that a is minus 10, so it's 25 take 10, which is 15. So question 25, last question. What we have is a, b, c, d as a parallelogram. So it's a, b, c, d. So the big outside shape is a parallelogram. So we need to know our properties of parallelogram. Opposite sides are equal in length. Opposite angles are also equal. So angle D and angle B are equal. Angle A and angle C here are equal. So there's lots of properties of parallelogram we might need to use. And we have E and F are points in A and B such that BE equals DF. So we're told this length BE equals DF, and that's why there's a small line marked on. And it's proving that triangles are congruent. So proving triangles are congruent requires a minimum information, whether it be that all three sides are the same length, or in this case, it looks like we might be able to use the fact that two sides and an included angle are the same. So how do we prove that? Well, we need to be very clear. Firstly, that if we just look at the two triangles we're trying to show are BCE and DAF. So there's one of the triangles, and there's the other triangle. So it's those two triangles trying to show they're identical. So the first thing is that DF equals BE, DF equals BE. No reason needs to be given because it's given in the question. Second thing is that I know that this angle here is the same as this angle up here. So angle, and let's be clear, I could write angle D equals angle B because there's no sort of ambiguity, but let's say angle ADF equals angle EBC, and you need a reason. Okay, your reason is opposite angles in parallelogram are equal. Opposite angles in parallelogram are equal. Alright, so take your time to write that out. Opposite angles in parallelogram are equal. Then on to the second bit, we have as the side an angle and another side to be equal. Well, hopefully we realize that this side AD is equal to BC. Right, those two are equal, so AD equals BC. The reason, and once again, parallelogram. Okay, I'm not writing it down, it'll take me too long, but basically opposite sides in a parallelogram are the same. You need to say for your final mark, so by side, angle, side, the two triangles are, okay, keep writing, the two triangles are congruent. The last part of the question is to deduce EC is parallel to AF. So EC is this length here, and we need to deduce it's parallel to AF. Now it looks parallel, but we have to prove it. So we've got to prove that it's parallel. So to do that, one of the first things I would maybe say is that, let's see, AB and DC are parallel because it's a parallelogram. Because the two triangles are congruent. Alright, so if you could write down the triangle BCE and triangle DAF are congruent. So you can see from the picture that what we're saying is because this is parallel to this, because these two triangles are congruent, then it must lead to that and that being parallel. So just a final sentence to say that. And one thing I want to say is don't write outside the box of the bit there should not be written. That will not be seen on the marker's screen.